Well, hello there, ladies and gentlemen. In this video, we're going to talk about solving quadratic equations by factoring. And, well, we're going to see some stuff like this, some stuff a little simpler, some a little trickier. We're going to talk about the why, what, how, when, some of the tricky things. Let's get to it, shall we? So, here's what we're going to do specifically. We're going to learn when, why, and how to solve a quadratic equation by factoring. And in order to be able to do this lesson, you first have to know how to distribute, because factoring is backwards of distributing. And then, of course, you have to know how to factor. You're going to have to know some basic inverse operations. You're going to have to know the zero property. And then you're going to have to know how to identify if something is in fact a quadratic equation or not. Last one's really easy, right? If it has the degree, the biggest exponent of 2, it's quadratic. Things you're going to learn in this lesson, well, apply. So let's get to it, shall we? Let's first talk about the when would you factor to solve a quadratic equation. Well, first, if the instructions say, hey, factor it, then do it. And if the instructions aren't specific on your method that you're going to use to solve the equation, if it's factorable, you should, because, well, the reason why you should factor is because it is simplest. You're going to make fewer mistakes. It is faster. It's the least complicated. It is the KISS method in action. Keep it simple, stupid, right? So the simpler, the quicker, the better. So let's talk about how to solve. So the way we're going to solve these equations by factoring is we're going to first get the equation set equal to 0. Then we're going to make sure it's written in descending order, ax squared plus bx plus c. Then we're going to make sure that a is positive. Then we're going to start to factor. Then we're going to use the zero property. So let's do that, shall we? Let's see our very first example right here. So example number 1. Let's say we had to solve this by factoring. X squared minus 2x equals 35. So first and foremost, if you're dealing with a quadratic equation and you have an x squared and an x term, you won't be able to solve using inverse operations. You could use inverse operations to get everything on one side, and you can use the order of operations to get it in order, but you're going to have to either factor, use completing the square, or the quadratic formula to solve the equation. Okay, so for in this one, we're talking about factoring, so these are all going to be factorable. So the first thing we want to do is we want to get this equation set equal to 0. The way we're going to do that, we're going to use some basic inverse operations. We're going to subtract 35 from both sides, and what we're going to get is negative 35 plus x squared minus 2x equals 0. Now, of course, you could have written it in order already, but sometimes you don't think ahead like that. So all you got to do is rearrange this a little bit. We're going to swap the negative 35, put it where c belongs, and we've got x squared minus 2x minus 35. Now we're going to factor it. This one's easy because the leading coefficient is 1, so we just have to figure out what two numbers multiply to negative 35 and add to negative 2. Well, that would be negative 7 and positive 5, right? And then we're going to go ahead and use the zero property. So we're going to take each one of these and set them equal to 0. So either this number is 0, this entire thing, x minus 7, is a number, and it's times this number, which is x plus 5. So either this number is 0 or this number is 0. So we're going to find the values of x that will make that true. So x minus 7 equals 0. Well, you could use inverse operations, or you could just figure it out, right? 7 is what x must equal for that, and negative 5 for the other. And boom, we are done. Now let's briefly put some context here. When we're solving this, here's what it means. If you were to graph this function, which is where we're going soon, these solutions, 7 and negative 5, those are your x-intercepts. That's where your graph is going to cross the x-axis. Now we have a y-intercept, which is negative 35, and we have a vertex, which we're going to use the formula to find as well. But we're doing this piece right here by factoring right now. Okay, so before we move on, think about it. What is going to make this tricky? Well, in my experience, the thing that makes this the most tricky for students are factoring basics. So let's review those really, really quickly. This is a crash course. We're going to do it very fast. If you don't know how to factor, you're going to have to go back and do some research. But hopefully, if you're just a little rusty, this will give you the, clue you in on the stuff you've forgotten. So we're going to be talking about a quadratic, like ax squared plus bx plus c. This is called standard form. I know it's quadratic because the biggest exponent is 2, right? Now, first thing you want to do is you want to look at a. If a is 1, then what you're going to do is you're going to see what two numbers multiply to C, called the constant, and the same two numbers add to B. And remember, you have to ask those questions in that order. What multiplies to C and adds to B? So for example, let's say we had x squared plus 8x plus 16. Well, A is 1. It's 1x squared. So what we're going to do is we're going to see if we can figure out if there's a pair of numbers that multiply to 16 and add to 8. Well, that would be 4 and 4. 4 times 4 is 16, and 4 plus 4 is 8. So factoring would be x plus 4 times x plus 4. Boom, done. All right, so now let's talk about what happens if A is not 1. What we're going to want to do is we're going to want to use the most basic, simplest, most fundamental thing of factoring, and that is going to be to undistribute something that's in common. So for example, here we have 3x squared minus 6x minus 9. So A is 3, right? If we can divide something out of all three terms, then maybe we can end up with a situation like our first situation where A equals 1. So here, 3, 6, and 9, those all have a common factor of 3. So we can take the 3 out. And then what's left in the parentheses does have a leading coefficient of 1. We have 1x squared minus 2x minus 3. That whole thing's being multiplied by 3. So we can factor this. We can say, hey, what multiplies to negative 3 and adds to negative 2? Well, that'd be negative 3 times 1, or negative 3 plus 1 for this part, right? Then you could use, if you were solving this, you'd just take each factor, set equals 0, solve it, you're done. Boom. Now, here's the more tricky situation. If A is not 1, and there's not a common factor, the best way, I believe, is guess and check. Now, if you have another method you like to do first, or instead, you're more than welcome to do that. A common one is taking the product of 15 and 8 and then factoring it and seeing which factors add up to 2. I think that's a ton of work, and I think this is much easier, guess and check. So let's talk about how guess and check works, right? So what you're going to do is you're going to guess what two numbers multiply to 15. It could be 3 and 5. It could be 5 and 3. It could be 15 and 1. We don't really know. We're guessing. And then you guess what two numbers multiply to make negative 8. Well, because of the negative sign, it's a little tricky, right? But it could be 2 and 4. It could be 8 and 1. We're not really sure. So this is a guess, 3x and 2 and 5x and 4. I know this is a valid guess because the first two multiply to make 15x squared. The last two multiply to make 8. So now let's check. Here's what you check. You check the outside and the inside. So the outside is 12x. The inside is 10x. Now here's the thing. I know that this is these two numbers here, this 4 and this 2, are different signs. They have to multiply together to make a negative 8. Only way you can get a negative when you're multiplying is if the signs are different. So that means these are going to be different numbers, different signs. So when I combine them, I'm left with 2x. Could be a positive or negative depending on how we assign these signs, but a 2x is what we want. So now I just have to figure out which one's positive and which one's negative. We need a positive 2x. That means the 12 would have to be positive and the 10 would have to be negative. So that is the trickiest type of factoring, but it's one that's not going to go anywhere. So if you need some practice with guess and check, I will put a link in the description. You can freshen your memory or refreshen it, however you want to roll, right? All right, let's see another example. So this one right here, negative 2x squared minus 7x plus 15 equals 0. Oh, this is an ugly one. Well, first thing we want to do is we want to get it set equal to 0. We're already there. So then what we want to do is we want to put it in order, which it is in order, but we want A to be positive. A here is negative 2. So, man, how can we handle that, right? We got a negative 2. We want it to be a positive. So all we're going to do is, and this is what we're going to do every single time, we're going to take a negative out of all three terms. We're going to factor a negative 1 out. Do you see? This is exactly the same value as the original because if you distribute negative 1, you get negative 2x squared, you get negative 7x, and you get plus 15. You see? So now what we've got is we've got a quadratic 2x squared plus 7x minus 15. There's not a common factor between all three terms, so we can't take anything out. So we're going to have to use our good old buddy guess and check to factor this, right? So this is what the factors are. You would guess 2x and x, and then the 15, you're not really sure, right? It could be 5 and 3. It could be 5 here, a 3 there. It could be 1 and 15, 15 and 1. We're not really sure, but this is correct, and I know it's correct because the outside makes a positive 10, and the inside makes a negative 3. Positive 10 and negative 3 makes 7. So the outside and inside check out. And the first two make 2x squared, of course, and the last two make negative 15. So this is correct. So now we're going to use the 0 property to go ahead and finish solving this. So either negative 1 is equal to 0, which is impossible, of course, or this number, 2x minus 3, is 0, or this number, x plus 5, is equal to 0. These things in parentheses are grouped. They're a single number. Like whatever x is, this number here is 5 more. Whatever x is, this number is 3 less than twice of x. So we're going to have to solve these, right? So this first one's impossible. And then for these, we're just going to use inverse operations. We're going to add 3, and then you're going to divide by 2. And over here, you're just going to subtract 5. So our two answers are 1.5 or 3 over 2, and x equals negative 5. All right, let's move on to our last example, something really ugly. What if you ran into something like this? Man, you might be thinking, that's unfair. I haven't seen anything like that. Well, that's true. Maybe you haven't, but this is still how we're going to go about it. This is going to be our guide. We're going to first need to get this equation equal to 0. So that means we either need to move all of this to the right or all of this to the left, and it's your choice. So I went ahead and decided I was going to move the 8 minus 8x to the right side by using inverse operations. So I'm going to subtract 8 and add 8x to both sides. And then I'm going to go ahead and simplify it. Now these over here make 0, right? 8 minus 8 is 0. Negative 8x plus 8x is 0. So you're left with 0 equals 3x plus 1 times x minus 1 minus 8 plus 8x. Just move that to the other side, right? Now, we have it equal to 0. That's true, but it's not in order. And I'm not really sure if A is positive or not. We're going to have to see. So to make this written in order, what we're going to have to do is we're going to have to multiply these together. It's maybe not obvious why to do that. And you might not be even sure if that's the way to do it, but it's going to be. So you have to get this in ax squared plus bx plus c form with a positive a before we want to start factoring. So we're just going to multiply these two things together. So it's going to be 3x squared, right? Minus 3x plus x minus 3x plus x makes negative 2x and minus 1. See, so you multiply those together. This is what you get. Now all we got to do is just combine like terms. We have a term with a negative 2x and a positive 8x. They're on the same side of the equal sign, so we're just going to combine those. And of course, negative 1 and negative 8 make negative 9. So now we have this equation. From this equation, a is not 1, right? But like we saw earlier, we can divide a 3 out of all of this. Do you see we can take a 3 out of that? And then you can factor it. This is pretty easy because now it's just 1 multiplies negative 3 and adds to 2. We did one very similar to this just a minute ago. And set it equal to 0. Solve it. You're going to get x equals 3 and x equals 2. Boom, done. So in this lesson, we were supposed to learn when, why, and how to solve a quadratic equation by factoring. So you do it if the instructions say so. Or if they don't say and you can factor, then you do. And the reason why, this is the simplest way. It might not seem simple, but it is simpler than using the quadratic formula. Certainly easier than using the completing the square method. And that's how we do it. So then you needed to make sure you know how to distribute and factor, which I hope you got. If not, I'll leave some links in the description that can give you the basic help you need. The basic inverse operations, you use that to move everything to one side. You use the 0 property to set up your 2 equations, and then boom, you're done. And hopefully you know when it's quadratic and not. If the degree, the biggest exponent is 2, it's quadratic, and everything you've learned in here can be used. So anyway, hope it's been helpful. Hope it's been useful. You guys have a wonderful day, and I'll talk to you soon.